study higher mathematics? Now this question has often come in our minds. That is why I want to extend my heartfelt gratitude towards mathematics department for giving me this opportunity, which motivated me to explore more on this topic and to present it in front of you all. Before coming on to the question why, let us discuss what is modern mathematics. Modern mathematics is broadly classified into two, pure and applied. In pure mathematics, we study number theory, algebra, analysis, etc. And in applied, it is differential equations, numerical analysis, operational research, etc. Now, coming on to the applications, let us first discuss about differential equations. Differential equations, we can say it as mathematics of changes because it involves changes with respect to the independent variable. This independent variable can be time, can be mass, distance, anything. So its applications in rocket launching. When a rocket is launched, we see that the exhaust which comes out, because of which its mass decreases and its velocity increases. So, and when it enters into the space, its parts detaches from the main body. Because of that too, its mass decreases and velocity increases. That is why we can see a constant change in velocity with respect to the change in mass. So, because of this, we can extract an equation through which we can know that at what time the rocket will enter in a particular orbit of a planet and at what time it will reach there. Also, through differential equations, we can tell about that in how many years an asteroid or two asteroids will collide or it will come closest to the Earth. This you can see the ideal equation of rocket. Here, this is the change in mass, because as the exhaust is coming out, the mass is decreasing and its velocity is increasing. You can see it is mdu minus dmv, that is change in velocity with respect to the change in mass, and through this the equation of rocket launching has been derived. Now we have quite often seen that in gym, when the weight is being pulled, then there is this chain which is attached to the dumbbell, the weight. In this, two differential equation is used. How? As the dumbbells are pulled up, so there is a change in distance. We can see this dx, and with that the mass also changes, because as the dumbbells are pulled up, this chain becomes heavy because it is also pulling up. So there is change in distance with respect to change in mass, and this we can see here when we calculate its equation. That is, the motion which results by something as simple as pulling a chain upwards has to be expressed through a not so simple second order differential equation. And how it came, we can see that the mass of the chain is the weight, which is 10x. When we put it into the equation and solve it, it will come like this. Now, the differential equation has its application in economics too, where this is Black-Scholes equation used for option pricing and financial market. You can very well see the use of partial differential equation in this, and here too. It has diverse applications such as climate modeling, neural activity, in fluid dynamics, machine learning, etc. Another application we can see in population growth, where we can see that the total population after a certain time t is given by this equation, where P0 is the starting population and the R is the percentage rate of growth and the time is constant. Another diverse use of differential equation is in Maxwell's equations. We all are very well aware of the four Maxwell's equation, which has its use in electromagnetism, mobile phones, Wi-Fi. Now this is very interesting. The mathematics used to solve crimes. Now let's see how. Imagine this is of a city where a group of people are committing crime on a regular basis. And these are the 5 spots, the darker ones, these are the 5 spots on which they have committed the crime in past few months. So how can we catch these people using mathematics? Let us divide this location in a grid format in the squares and name, and let's pick a particular random square which is in ith row and jth column, and let's name it pi, comma j. Here pi, comma j is the probability that the criminal lives in that square. So for solving this problem, a PhD criminologist, Kim Rosmo, tried to find a formula that could find the criminals where the criminals likely live. And below this, it shows the distance between the grid and the crime scene. Like how we have chosen this square to be the reference point or the probability where the criminal lives, and these are the 5 spots. So let us suppose we want to calculate the distance of this square from this particular spot. So we can name it as capital Xi and this as small xn. So the distance will be mod xi minus xn, and the same we will do with y coordinates. So this whole term will be the distance of the square we have chosen